In today's lesson, I'll be showing you how to use the sine rule to solve for unknown sides and angles in non-right angle triangles. So usually what you were given before were you were given right angle triangles, and if you were given right angle triangles and you were solving for unknown sides and angles, it was sufficient enough to use just the SOHCAHTOA ratios. So now we're dealing with non-right angle triangles, so we can't use the SOHCAHTOA ratios. So before we begin solving problems, we should write up the sine rules are. So there's two sine rules, one for sides and one for angles. So we'll begin with the sine rule for side. So we're solving for unknown side. It's lowercase a over the sine of uppercase A equals to lowercase b divided by the sine of uppercase B equals to c, lowercase c, divided by the sine of uppercase C. So that's for solving unknown sides. So if we're solving for unknown angles, we invert those fractions. So instead of A over sine A, it's going to be sine A over little a, sine B over lowercase b, and sine C over lowercase c. So to get these letters, we need to deal with the conventions of non-right angle triangle. So with non-right angle triangles, we usually denote our angles with capital letters. So let's start with this triangle. So it's triangle ABC. So our uppercase letters are our angle, and our lowercase letters are our sides. So the lowercase sides are actually always opposite the angle. So if you're looking at A, the side opposite A is going to be lowercase a. So that side is opposite the angle A. And the side opposite angle B is lowercase b, and the side that's opposite C is lowercase c. So we can see that if we look back at the two rules, we can see that we've actually have three sets of fractions. So it's not necessary for you to use the three sets of fractions to solve unknown sides and angle. Two sets of fractions is enough. So if you're looking at two sets of fractions, that tells us that we need at least two sides and two angles to actually use this rule. Two sides and two angles. So that's the condition for using this rule. If we're not given two sides or two angles, we'd be using a different rule to solve for our unknown sides and our unknown angles. So we'll start by solving the first question. So the first question, if you scroll down, okay, so first question is this one. So this is our first question. I should label it number 1. And we're going to solve for CB. BC. Alright, so before we start, we should actually label our sides. So our angle's already labeled for us, so we don't need to do that. But we should label our sides using lowercase. So looking at angle B, the opposite side to angle B is lowercase b. The side that's opposite angle A is lowercase a, and the side that's opposite angle C is lowercase c. Once you've labeled your sides with the lowercase, let's refer back to the sine rule. So the sine rule was, so we're solving for unknown sides, so it's going to be A over sine capital A, B over sine capital B, C over sine capital C. So that's our rule for unknown sides. So we're going to go and substitute it in. So our A becomes BC because that's what we're solving for. A is replaced by BC, and we're going to change uppercase A to 53 degrees, We'll keep B as is because B has no information. We don't need to change it to CA at the moment. And we'll keep sine B as is. So the next one is C. C is going to be replaced by 7. And the sine of C, so the angle C is 43 degrees, so we'll replace C with 44 degrees. So what we have here is we have 3 sets of fractions or 3 sets of ratios. We don't need 3 sets to solve for our unknown sides. 2 is sufficient. So what I'm going to do is I'm going to compare this ratio with this ratio. So eliminating the need for the middle ratio. So combining those two ratios, we have BC over sine 53 degrees equals to 7 over sine 44 degrees. So now what we're doing is we're going to solve for BC. So to solve for BC, I need to get rid of this denominator. So getting rid of denominators in maths requires us to multiply both sides by the denominator. So I'm multiplying both sides by sine 53. That should cancel out. And we're going to times this to sine 53. Since we're looking for an unknown side, our answer should be a decimal number. And if you input all of this into your calculator, you should get 8.047766799. And the question hasn't stated where to round off, so let's round off to 2 decimal places. So it's going to be 8.05 kilometers. So that's what BC stands for.